Okay. Joe? Joe? Have a seat, please. Okay. Do you remember what A was called? That was called the starting value. Because when x is equal to 0, then y equals A times B to the 0. And what's B to the 0? What's any number to the 0? It's 1. So it's just equal to A. So that's this value right here on the y-axis. That's A. Whatever it is. So you should write this down on your notes. You may use your notes on your quiz, test, whatever you want to call it. Okay, Cole? Have that written down? No. No. And remember what was true about B. We haven't investigated anything that's decaying yet. So if B is greater than 1, we have growth. And that's all we've been doing. Do you remember what those look like? And we need to know this in our math classes. Okay, Taylor, can you see okay? Yeah. Except that you're supposed to sit back there. Then you could see better. Or in the middle. Okay, so we started A, and this is the growth. It grows like this. I don't really care how steep you make it. I want the shape. Okay, Henry? I just want the shape. Over here, it's going to come down like that. So this is growth. And B is greater than 1. B also in these equations is called a common ratio because we have sequences with common ratios. So B is equal to the common ratio. Do you remember that from last week? But tomorrow is the last lesson in this unit. It's the last lesson for the year. And then we just review. We would review all week. I put the schedule on the board with our test on Friday. And then next week is a short week, 4 days.
This Friday?
This Friday. Mm-hmm.
So what do we do for the last?
Wait, what? Not many days left. Yeah.
Why do teachers give us like tests and quizzes and stuff towards finals?
Because we're finishing the unit. Just happens to be where it is. Then next week we'll.
I feel like the last
we have review packets.
do it all finals. Like it shouldn't even be like.
It's only about a week's worth of material to review. So we have that all next week. Okay, you guys? Shh. No, not here. It's only 15% of your grade.
Finals?
Yeah.
What?
In the math class, it's 15%.
Oh, but in other classes.
Oh, well, I don't know about those.
Oh, I thought you were talking about.
Well, if you do, now listen, if you do, it will lower your grade. It could be from an A to a B+. It can lower your grade. It can also bring you up. If you do really well on your final and I look at B, B, A, I might give you the A or at least a higher grade than the B's. Because if you can do it on your final, that means you really did learn it. Maybe at a later time than when I tested all year. It is for me.
Okay, so you're one out of 6.
For my classes, yeah. I don't know what the other teachers do. Okay. Okay, guys. A week from Joe, a week from this Friday, we have a block schedule day. So I'll see you Friday. Oh, no, I won't because I'm going to be gone. 1, 3, and 5. And so that'll just be a review day. Okay? Now, this is all we've done so far is this growth piece. And you guys have asked me questions. Okay, Joe, pay attention. You've asked me questions. Well, what if B is less than 1? So if B is between 1 and 0, and B cannot be negative. Okay, B is always a positive number. Does that mean my common ratio is always positive? No. It does for exponential equations, but if I'm talking about a geometric sequence, no. Face the front, please. Okay. This is decay. Where's your starting value here? Ray, what's the starting value? When x is equal to 0, what's y equal to? So y equals A times B to the 0. I don't care what B is. Any number to the 0 is 1. Joe, put your phone away, please. Joe, do you want me to send the video home to your parents? Yeah, that's for my mic. Okay? Okay, guys, what's the starting value here? It's still A. We start there. So what am I going to graph on my graph here? I'm going to start at A. And now this is decay. You guys know what decay looks like. Yeah. Right, Henry? It goes down. It does this. It approaches 0. It never crosses 0. Exponential functions are always positive. And on the left side, it goes up. We will do some tables of values so you can see why it is what it is. And this is decay. And where do we talk about decay? Because we talk about it all the time. I'm going to try to adjust that. Where do we get decay? Right now, gas prices are sky high. I would like to see it decay. The gas prices, because of the they're working on refineries in Illinois. That's why. He can start working on his review packet. Yes. Yes, they are. Okay. But you guys, okay, Ray, how do we heat our houses? Besides coal and water power, we also have nuclear energy. Okay, Taylor, put that away, please. That's decay. The problem is all the stuff you're left with, Ray, at the end, all that nuclear residue, whatever you want to call it, waste, decays. Does it ever go to 0? No, it has a half-life. If the half-life is 100 years, then if you start here, it's going to take 100 years for it to be half as strong. That's the problem. What do we do with our nuclear waste? Burying it is not going to be the solution to the problem. Pardon? No, we won't do it in this class, but you do probably maybe done it in science. Probably in science. Well, that's what this function is. That's what this equation is. And B will be 1/2. There's other ways to express it. Okay, so that's what we're going to do. So is that going to be growth or decay? Joe, please don't. Joe, is this growth or decay? Decay. Because these are getting what? Smaller. Now, this is not necessarily an easy topic, by the way. Okay, what's our starting value? 75. Okay, some of you had some problems with that on a little worksheet. I'll hand it back. Okay. Now, how do you figure out the common ratio? You take this number, the 60, and divide by 75. Now, you could change it to a decimal if you want, or we could reduce it. Anybody know what goes into 60 and 75? 5 goes in. Do you know how many times 5 goes into 60? That's 12, and this is, how do I know? Multiply it out. Yep, it's 15. Can you reduce that again? What goes into 12 and 15? Taylor? Put your phone away. It's 2 lessons you got to listen to. That's it. Today and tomorrow. How about 3? So it's 4/5. Does anybody know what that is as a decimal? Well, I would like to make it a decimal, which means the denominator has to be 10. So I'll multiply that by 2 because I can. And this by 2, it's 8/10, or 0.8, or if you want to say 80%. That's your decay rate. We're not going to talk about the percent decrease till tomorrow. Right now we're just finding R. So R is equal to 0.8 if you prefer a decimal. 4/5 is fine. Okay, put that away, please. See, Henry, this is the problem. You're distracted. Yep. Okay, let's try the next one. Oh, that one Mr. Johnson threw out, I don't know. I didn't try it. Anybody want to try that? 31 divided by 168? This would be your starting value. I have to bring up my calculator. I didn't try it, didn't have time, and I didn't have a calculator. Why is this not working? Who's got a calculator? Ah, there it is.
I have
I'm just curious to see if it makes a difference. Where's your calculators?
In your bag back there.
No. They've been borrowed for the exams. So I don't have any in here, but you should have some on your iPads.
I have it on my phone.
Okay, I'm just going to view.
She just gave you the answer.
I don't know what the answer is. Who? Okay, so we're going to take 31.0632 divided by 168. Oh, I don't want to see that. There. 0.1849. Now I'm going to bring this back. Now let's see if there's a common ratio. Mr. Johnson didn't do it, so I'm wondering if there's a mistake here someplace. Maybe it's not geometric. Okay, Joe, what do I have to do now? I have to take this 13.357176 and divide by the 31.0632. If I don't know if it's geometric, I'll do that. I typed something wrong. Oh, that's a delete. Okay, I should have an insert. Second insert decimal point. Hit the wrong button. Story of my life. Okay, is this geometric? Joe, is that geometric? Is this number the same as that number? No. So guess what? I can't do it. It's not geometric. Not sure what to do with it? I would need more data points than those to decide what it does look like, and then I could put it on my calculator and do a fit. I could do that. Right now, so we'll just say, guess what? It's not geometric, can't do it. Okay, let's graph this. Now, I don't like decimals. Taylor, put your phone away. To me, this is easier, okay, guys? This is easier as a fraction. What is 0.25 as a fraction?
I missed that last page. I'm sorry.
You can't do it. It's not geometric.
Just write no on it.
No, it's good enough. Okay, Henry. What is 0.25 as a fraction? Guys, we'd be done by now. Come on.
0.25/1.
It's 1/4 to the x. What's the starting value? There is a number there. I just don't see it. What number's in front here? A 1. Right? Joe, do you need to go to the SBR room? I don't have any issues with that. Joe, what is 1/4 to the first power? This is an easy one.
The same thing.
It's 1/4. What's 1/4 to the 0?
1.
It's 1.
Anything. 1.
Now here's the problem that we were having. What's 1/4 to the -1? Let me write it. It's 1/4, nope, to the -1. Now the negative says, I don't like negative exponents. I've been doing negative exponents for years. I don't like them. So I'm going to change it to positive. To do that, I flip this, the reciprocal. Okay, Taylor, so it's 4/1 to the what? First. It's never a negative number. Now you notice I never say never.
Okay,
So that's 4. What about, okay, you guys, what about 4 to the -2? Cole?
there you go.
I'm sorry, what's 1/4 to -2? Well, it's 1/4 to the -2, which means, okay, go pick it up and then go take your stuff to the SBR room. Okay, what does that mean? It's 4/1.
It's still relative.
I'll wait. Very good, Suzanne. Now be careful, Cole. Is that 8 or is that 16? Cole? That means 4 times 4.
16.
That's 16. Okay, because you're going to have some problems in the homework that looks like this. Henry, well, you won't do it anyway, so. My pencil. Well, I'll rescue it. Okay, so let's graph this. When x is equal to 1, I'm going to go to 1/4. There's 0, there's 1. Not very big, is it? Actually, I put a dot there. It's pretty good. When x is equal to 0, this is at 1. Okay, Joe? When x is equal to -1, what point am I going to graph? No, it's over there in the graph. -1 is going to go up to 4. These are exponentials. They decay and they grow very quickly. Yeah, I definitely don't want to lose my pencil. I only have 4 left. And at -2, it's what? -2 is to the what power? 16. Look how fast that decays. So it's going to do this. What do you need, Joe? Yeah, not right now. Maybe not ever. Okay, is that okay? How about girls in the back? I'm kind of ignoring you. Is that okay? Let's try the next one. Okay, this is what you're going to have to do on the worksheets. This is the right next problem. It's not that long. So we got 3 problems to do, actually. So is that growth or decay? Is it getting bigger? Good, it's growth. Now, how do you find the common ratio? You take this number and divide by that. So it's 5.15 divided by 5. It's not, is it? It's 1.03. Not growing very fast. That's a small number. How much is it? Pardon? It's going to be increase. How much, though? Now, do you remember how to do that?
No.
To find the percent of increase, you want to see how much bigger. What happens when I have y equals 1?
3%.
When y equals 1, it's this. If we're talking about growth, it's going to be this. I just want to see what the difference is between these two things. When we start doing decay tomorrow, we do the percent decrease, it's going to be below this. So what you do is you take this and you subtract 1 from it. 1.03 minus 1.00 is 0.03, and you change it to a percent.
3%.
That's right. Change any number to a percent, we multiply by 100%. Or 3%. Now, do you remember how to write the equation? I don't want the percent increase when I write the equation.
Wait, can I start? All right.
Well, let me write the basic. Y equals AB to the x.
There we go. Done it.
What's A?
A is the start.
Yeah, what was it?
5. One jumping.
It's 5.
Oh, I thought I put down.
Now, what's B?
1.03.
1 point. It's going to be growth if this is bigger than 1. If it's equal to 1, it's a horizontal line. There's no growth to the x. That's it. Is that okay? Ready to go to the last? No, it's not. It's the last one of these, but then we'll do a little review problem. Is that growth or decay? Joe, what is this? What'd you say, Joe? Did you answer? Oh, okay. What's the common ratio? What do you do with the 27 and the 30?
You divide.
And you may use a calculator, or I'll have a calculator handy. So I'm just going to reduce that. What goes into 27 and 30? 9 doesn't go into 30. 3. So it's 9 out of 10, which you may use that, or you can say 0.9. They're the same.
90%.
Okay. It's a decrease. So now how are we going to do this? How do we find our percent decrease? You still subtract 1. So it's 0.9 minus 1, which gives you negative 0.1. And the fact that it's negative means it's a decrease. The percent of change is going to be the 10%. It's a 10% decrease. That's what this means.
You say negative 10%?
You can. It's better to write 10% decrease.
How is 9 minus 1?
0.9 minus 1 is negative 0.1.
Understand.
Get my calculator out?
This is negative 0.10.
Yeah, that's the same, isn't it? I'm going to clear that. And I want 0.9 minus 1. Now, you could just subtract it and know that it's going to be negative. But there it is, negative 0.1.
I did not believe it.
because is 0.1 the same as 0.10? Why do I want the 0 at the end? Because I want to change it to a percent. Is that the same as this? You can add as many zeros at the end as you want. At the end. You can't put it between the decimal point and the number. No. Well, it's 10,000 over 10 over what? 100,000, which is 0.1. It's 1 0. How many zeros I got there? 1, 2, 3, 4. And then the place is 1. And then I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Still 1/10. Got to keep the same value. Isn't that lovely how math works? Nothing else works that way. Except cars, which is math. Your DVD players, which is math. It's all math. Yeah. The which one? I haven't done it yet. It's y equals a times b to the x. All math. What's our starting value, Suzanne? Shh. Where do you start? 30. And if you take 30 and you multiply it by 0.1 or 1/10, you'll get the decrease. Okay, so what do I want here? I actually want 0.9 here, don't I? I don't want the percent, do I? Do I want the percent or do I want the common ratio? I want the common ratio.
I already forgot this stuff.
That's why I'm reviewing it.
The general form.
It looks like this. Those are all your exponentials, so when you do them in science class, that's what it's going to look like. Okay. Get a chance to practice it. Put that equation in general form. Oh, that's what he's talking about? Remember general form?
Yeah, that's what I'm talking about.
It looks like y equals ax squared plus bx plus c. Well, let's do it together. What should you do first? Order of operations. Multiply it out. You're doing your exponents. Is that x squared plus 4? Oops. No, I won't say that. It's x squared. Joe, do you remember how to multiply that? X plus 2 times x plus 2. Joe, do you remember how to do that? Cole? You told me you didn't remember. It's x squared plus 2x, but for people who don't see, plus another 2x. Joe, pay attention, please. This is on your final exam, which is why it's on all those worksheets. Plus what? 4. And I still have a minus 5 there. Then I should combine similar terms. I should do whatever in the parentheses. Absolute value, I don't care what it is. But anything that's in parentheses, I should do. It just had to have a little board space. So y equals 3. Can we add anything in there?
Yeah.
Can't we add these? How much is that, Joe? So it's x squared plus 4x plus 4. Order of operations. What do I do next? I distribute the 3. Do you remember that? Okay, so 3x squared. Don't forget to do the 3 times the 4. A lot of you like to forget that. But it's plus 12x. Think of everything in this parentheses gets multiplied by 3. It's not fair if you don't do it. Plus 12 minus 5. Anything else I can add or subtract? Yeah. Very last thing I do. So y equals 3x squared plus 12x plus 7. That's general form. Okay, Ray? Joe? Now, I should be able to collect this before you leave, before you sometime during the day, hour. And that's all there is. Now, I'll get you the new worksheet, but I'll hand back the other ones. I believe everything's